Hello everyone, welcome to CSCI287 Data Structures Hands-on Practice. In this video, we will introduce binary tree implementation in Java. In particular, we will focus on how to implement the add and addRecursive methods in the binary tree class. The purpose of the add and addRecursive methods are adding a new node with a specified value into an empty slot in the binary tree. In fact, we only need addRecursive method to achieve this goal. In this hands-on practice, we implement this feature with two methods in order to demonstrate one of the access specifiers, private. Private is the most restrictive access level. Only the class in which a private method is defined can call that method. In this hands-on practice, we define addRecursive method in the binary tree class as a private method, which indicate that we can only call addRecursive method in the binary tree class. Contrarily, we define add method in the binary tree class as a public method, which indicate that we can call add method from other class. For example, assume we create a binary tree in a class named test. In the test class, we cannot call addRecursive method, but we can call add method. In order to add a new node to a binary tree, we implement the addRecursive method based on the following rules. As shown on the screen, the root node of the binary tree holds value 5. We take the root node as current node and compare the new node to the current node. Assume that the value in the new node is 3. If the value in the new node is less than that in the current node, we take the left child pointer to add the new node as the left child node if the pointer is null. Or we follow the pointer to take the left child node as current node and repeat the comparison step. Similarly, assume that the value in the new node is 8. If the value in the new node is greater than that in the current node, we take the right child pointer to add the new node as the right child node if the pointer is null, or follow the pointer to take the right child node as current node and repeat the comparison step. In order to implement these two methods, first, we create an addRecursive method in the binary tree class. As aforementioned, we define this method as a private method which can be invoked within the binary tree class. This method should take the root node as current node and the value of the new node as input parameters, and return the root node. First, we create a header of the method. The first parameter is a node type. It's current node. The second parameter is the value for the new node. As a recursive method, the first step is we need to implement the terminating case. The stop condition is when the child node is empty, a new node with the input value can be added to the empty slot. So if current equal to null, then we will create a new node with the input value. Otherwise, we are going to perform the comparison. If the value is less than the current data, the current node, that's the first condition. Else, if the val is greater than the current data, the current node, the third condition is equal. Okay. When the value in the new node is less than the current node, we are going to explore the left branch. So to explore the left branch, we call the recursive method. And we send the left child send the pointer and also the val. So the return should go back to current.letChild. Similarly, when the val is greater than the current node, then we try to explore the right branch. So the current.rightChild equal to addRecursive val. Okay. The third condition is the value already exists in the tree. So that we have the equal, the val equal to the current node value. So in this case, we will show system.out.println. We display a message. The value already exists. Okay, in this case, we are not going to add any node. Okay, so this implement the addRecursive method. So similar, we are going to implement the add method. As we previously mentioned, the add method is a public method. So the add method do not need to perform any return. and we just simply, in here, we receive the val, the new value. And in the add method, we just simply call the addRecursive. So we send the root and call recursive with the root and with the new value val. Okay, so once the addRecursive finish the recursion, the result will go back to root. Actually, that's the tree, the binary tree. All right, so now we can save the file, and then we try to compile it, make sure there's no problem, and we try to test run it. And there is no runtime error, so now the program should work. Okay, so in the next video, we are going to demonstrate how to implement the main method, and also we are going to implement a test class to show you the effect of the private. All right, thank you for watching. Bye-bye.